If you work in security or infrastructure engineering today, you know the feeling. You were promised simplification with the move to the cloud, right? The promise of abstracting away all that complexity. Instead, what did we get? This sprawling, infinite graph of microservices, permissions, and ephemeral assets that spin up and die before you can even log their IP.
Yeah.
It feels less like you're an engineer and more like a lifeguard trying to track 1,000 waves at once. You're just constantly drowning.
And that feeling of chaos, that complete lack of control, is exactly why the market for cloud security posture management, or CSPM, has just absolutely exploded. I mean, it's a multi-billion-dollar industry now.
Right.
It's no longer about whether you need it. It's about how you can possibly achieve visibility at scale. You just can't secure what you can't see in a modern cloud without some serious help.
But the moment you start shopping for that help, you are just hit with a wall of noise. You get bombarded with claims.
Exactly. Every single vendor claims they're using AI. Every vendor claims to be agentless. And of course, every vendor promises the holy grail of a single pane of glass.
Yeah, of course.
The reality is, when you peel back the sales deck and you actually look at the architecture, what you find under the hood is often very, very different from the glossy marketing.
So our mission today is to cut through all of that marketing noise. We're providing a clear analysis of the state of the CSPM market here in 2025, really focusing on how these tools actually work to justify their pretty substantial budget demands. And we'll be looking specifically at the big three platforms that are dominating the enterprise space: Wiz, Orca Security, and Prisma Cloud.
And if we're setting the stage for this, I think the single most important shift to understand is this. Modern CSPM is no longer that old-school, glorified spell checker for configurations, that basic functionality. That's just table stakes now.
Okay, let's unpack that. Let's unpack that evolution. We're moving beyond just, static configuration checks. What defines a modern CSPM tool today, and why did that old approach become obsolete so quickly?
Well, the first phase of CSPM was utilitarian. It would just query your AWS or your Azure API and tell you the basics.
You left an S3 bucket open.
Exactly. You left an S3 bucket open, your security groups are too permissive, and that was useful, but it fundamentally lacked the ability to measure actual risk. The whole industry has shifted so heavily towards CNAPP, the Cloud Native Application Protection Platform, because context is everything.
And context is. It's the relationship between those 1,000 ephemeral assets.
Precisely. The goal isn't just to generate a list of 10,000 misconfigurations. The best tools today, they visualize the relationship between vulnerabilities, identity access permissions, and network exposure. They build a graph model, a security graph of your entire cloud.
I think that relationship mapping, that's the real aha moment for anyone who's just buried in alert fatigue. Because a vulnerability by itself tells you almost nothing about the actual danger to the business.
Absolutely nothing. I mean, think about the difference in risk. You might find a critical CVE, a vulnerability deep inside a virtual machine that's buried in a private subnet. Zero external network access, zero permissions to touch production data.
So low risk.
Very low risk. You can patch it next quarter, it's fine.
But if that same vulnerability is sitting on an internet-facing server,
then it's an emergency, especially if that server also happens to have an exposed identity key that grants it admin access to your production database. That combination, vulnerability plus exposure plus excessive permissions, that's what we call a toxic combination.
Right.
And we are looking for tools that find those kill chains, not just the individual ingredients. That is the fundamental difference.
That distinction is just.
Yeah.
It's paramount. If the tool can't prioritize, you're just drowning in a more expensive kind of alert. Speaking of noise, let's tackle the most aggressive marketing claim we hear, the agentless lie.
Yeah.
This has been like a religious war in cloud security for years.
Oh, it really has. On one side, you have the agentless purists. They argue that installing code on every single host is just a non-starter.
A management nightmare.
A total nightmare. Performance degradation conflicts with existing tools. The operational overhead for DevOps is huge. And, I mean, Wiz and Orca, they built multi-billion-dollar valuations on promising to secure everything just by connecting an API role.
But then the defenders of runtime protection, they push back, right?
Yeah.
They argue that scanning a static snapshot of a disk is fundamentally reactive. You're looking at a photograph of a crime scene.
That's the perfect analogy. It tells you where the breach happened, but it doesn't stop the crime in progress. And that's where the reality of 2025 really is. The lines have blurred dramatically. While the leaders built their brand on Agentless, they've all had to acknowledge the necessity of dynamic analysis.
So if I need to stop an attack right now, like, block a hacker trying to drop a crypto miner, the agentless pitch just falls short.
It does, correct. If your requirement is to block attacks in real time to perform intrusion prevention or see exactly what's happening in the kernel during an attack, you need code running there. And that's why you see these agentless leaders now offering optional runtime sensors.
And they're usually using eBPF technology for that.
That's right, typically leveraging eBPF. It's a really powerful way to safely run programs in the Linux kernel without changing the kernel itself, and it gives you that deep, real-time visibility into what processes are doing.
So they basically realize that scanning a snapshot a disk, image misses all the critical runtime behavior. In-memory threats, command execution, all of it.
Exactly. A snapshot is a photograph. An eBPF sensor is a live video feed. They serve different purposes, but for your high-risk production workloads, you need the video feed.
Okay, so what's the actionable advice here for someone evaluating these systems? How do they avoid getting caught in that marketing trap?
Stop asking if they have an agent. Ask specifically. If I detect a new process trying to modify system files on my critical database server, can your tool block that action before it completes? If the answer is yes, you are installing a sensor. I don't care what they call it. The key is just distinguishing between detection and prevention.
That is an excellent reality check. Okay, so with the security graph and the agent versus sensor reality in mind, let's turn to the three market giants. Let's start with Wiz.
Wiz. Yeah, Wiz is the current market darling, and it's primarily because they solved that initial friction problem. Before Wiz, deployment was just painful.
They're the speed demon. What was their core promise that resonated so much?
Speed to value. The pitch was simple. Give us read-only access to your cloud APIs, and in 15 minutes, we will show you everything. All your assets, all your risks, all your toxic combinations. For a large organization drowning in sprawl, that was just irresistible.
And their entire architecture is built on that immediate security graph we talked about.
Absolutely. The graph maps everything. Configs, vulnerabilities, identity permissions, secrets. It's incredibly effective at telling you, hey, this EC2 instance has a critical vulnerability and it has an exposed key, and that key grants admin access over here. Their data model is really, really strong.
What about their 2025 AI features? They're pitching Gen AI remediation. That sounds incredibly useful, but also maybe a little risky.
It is. The goal is developer enablement. So instead of just saying, you need to fix this IAM policy, Wiz's Gen AI feature will suggest the actual code, the Terraform snippet, to fix it.
But is that where the catch is? Are engineers really willing to just copy-paste AI-generated code into production infrastructure?
That is the tension, exactly. It speeds things up for DevSecOps, for sure, but there's a huge trust barrier. You're relying on an LLM to write security-critical code. That requires rigorous validation. It just moves the problem from detection to validation.
And of course, the big issue we always hear about Wiz, the cost.
Yes. The brutal pricing. Wiz prices primarily per workload, and that can get catastrophically expensive in elastic environments. Imagine a retailer's flash sale. They surge from 500 nodes to 5,000 for just 3 hours. If your pricing is tied to that burst.
You get a bill that's scary fast.
Scary fast and impossible to budget for. And the rumors are that their minimum annual contracts start well north of $50,000, so they're just out of reach for a lot of mid-sized shops.
A tough trade-off for that speed. Okay, let's move to Orca Security. They tackled the deployment friction problem very differently with their side scanning tech.
Orca is the pragmatic choice. I like to call them the MRI for your cloud. Instead of running an agent inside the OS, Orca takes an out-of-band snapshot of your block storage, the disk image, and scans it securely on the side, so there's zero performance impact on the live server.
And crucially, because it's looking at the disk, it sees inside the operating system layer, which a simple API scanner would completely miss.
Precisely. That depth is Orca's key advantage. It can find a secret API key that's buried in some forgotten log file on a disk, or it can scan the actual version of SSH that's installed. That's information you just can't get from an API call. It's 100% coverage with extremely low friction.
And what's their big 2025 feature that you find compelling?
Their LLM-powered search. It really democratizes security data. Instead of being a query expert, you can just ask a natural language question, something like, show me all servers running an unsupported version of Windows that are exposed to the internet and can access our financial data. That ability to instantly connect risks is powerful.
But, like we said before, the trade-off is still there. It's runtime detection versus deep blocking.
That is their core limitation. Orca is fundamentally a high-fidelity scanning tool. They've introduced an optional sensor, but if your number one priority is aggressive intrusion prevention, you have to acknowledge that their depth comes from the scan, not the real-time block.
All right, finally, the heavyweight champion, Prisma Cloud. This is Palo Alto Network's behemoth.
It really is. It was basically built by welding together several best-in-category acquisitions.
And its strength is just the depth of features.
The sheer breadth of coverage. It's true code-to-cloud security, from standing infrastructure as code templates all the way to identity governance and compliance. If you're a global enterprise and you need one vendor, one contract for almost everything cloud security, Prisma is the default choice.
And their maturity and compliance is critical for regulated industries.
Absolutely. They've got the most comprehensive compliance reporting out of the box. Plus, they're FedRAMP High authorized, which is non-negotiable for banks, defense contractors, government.
But the downside of being built from acquisitions, that usually shows up in the user experience. What's the common complaint there?
Complexity. Without a doubt, it's complexity. Because it's stitched together, the UI can feel disjointed. You'll switch between modules that feel like they were built by totally different companies. But the biggest headache is their credit consumption model.
Right. How does that make forecasting so difficult?
Well, you don't buy licenses, you buy a pool of credits. And the consumption rate for those credits varies wildly. A basic config scan might consume 1 credit per hour. But enabling full runtime monitoring on a complex Kubernetes task might consume 10 credits per hour. So your finance team has no stable basis to project the annual spend. You're constantly worried you'll run out of credits halfway through the year.
So we have the speed of Wiz, the ease of Orca, and the depth of Prisma. But I want to touch on the specialist players because the generalists aren't always the best fit.
That's a crucial point. If your entire architecture is 90% Kubernetes, a generalist tool might actually dilute your focus. That's where a company like Sysdig shines. They maintain Falco, which is the open source standard for runtime security.
So they are the absolute experts for the nitty-gritty of container security.
Exactly. They are masters of eBPF for deep container runtime security. They can see exactly which process inside a container tried to open a reverse shell. Their weakness, though, is that their pure CSPM coverage, the API scanning, often lags behind the big graph models of Wiz or Orca. They're focused on the runtime fight.
Then you have someone like Lacework, taking a very different behavioral approach.
Lacework is the anomaly hunter. They use their polygraph technology. Instead of writing rules for known bad things, they map out what normal looks like in your environment. So if an IAM user who always logs in from London suddenly accesses a sensitive resource from an IP in South America,
they flag that as an unknown unknown.
Exactly. It's powerful for catching things you haven't thought to write a rule for, but
It requires patience.
significant patience. It needs a learning period, often weeks, to build a good baseline. And during that time, you're going to get a lot of noise. Teams need to be ready to tune it heavily.
And of course, for organizations all in on Microsoft, there's the native default.
Microsoft Defender for Cloud. It's baked right into the Azure portal. It's effective, it works well with Azure policy, and it's probably underrated because it's the boring default. A caveat, as you'd expect, is multi-cloud. The cross-cloud visibility just lags way behind a dedicated player like Wiz or Orca.
And rounding out the specialists, we have Tenable Cloud Security.
Tenable really bridges the traditional vulnerability management world with the cloud world. They're the Nessus people, the industry standard. Their cloud offering has particularly strong infrastructure as code capabilities. If you need to stop vulnerabilities in a Terraform file before they even leave the developer's laptop, Tenable has a very strong story.
Before we get to the final verdict, we have to talk about the non-optional drivers in 2025. This spending isn't just about best practice anymore, it's regulatory pressure.
Not at all. The huge financial push is coming from the European Union, specifically DORA and the NIS2 directive. These are not suggestions, they are mandates with major financial penalties.
And what's the practical difference between this and old school compliance?
Old compliance was a quarterly snapshot, a checklist. DORA and NIS2 demand continuous, verifiable digital resilience. That means your CSPM has to provide continuous monitoring and automated evidence collection, proving that gaps were detected and fixed in near real time. It's a whole different level of scrutiny.
So the platform has to have those frameworks just built right in and monitored.
Exactly. Tools like Wiz, Prisma, and Tenable have invested heavily in mapping their features directly to DORA and NIS2. For any organization operating in the EU, this is now mandatory.
Okay, so bringing this all together, there's clearly no single best tool. But if you had to summarize the best fit matrix for our listener, what does it look like?
It really boils down to your architecture and your team's maturity. If you're a fast-moving, multi-cloud company focused on DevSecOps and visibility is your biggest pain point, Wiz is probably your winner.
The graph is just addictive.
Yeah.
The gotcha, that brutal workload-based pricing.
And for the leaner teams that just want fast, comprehensive coverage without the agent management burden.
That's Orca. Side scanning is fantastic for removing friction and getting 100% coverage quickly. The trade-off is just knowing that for critical workloads, you'll need to deploy their extra sensor for that deep runtime blocking.
And finally, the large enterprise that needs maximum compliance, governance, and sheer depth.
That's Prisma Cloud. They're the comprehensive, safe bet for a massive organization that needs everything under one vendor. The catch is you have to manage that complexity and navigate that frustratingly unpredictable credit model.
So we've covered the marketing claims, the architectures, the specialists, the pricing pitfalls. Before we finish, what is a final practical piece of advice for someone about to start this process? Do not trust the sales deck. Do not trust the magic quadrants. These tools look incredible in a PowerPoint showing 0 alerts on a clean demo environment. The only way to know if they work for your chaotic environment is to test them. Get a trial, connect it to a non-production account, and run a controlled attack simulation. See if the tool actually helps your team fix problems, or if it just adds another row to a giant CSV file that nobody ever reads.
Which just turns into expensive shelfware. That is the ultimate test. And that brings us to our final thought for you to consider. When you're evaluating any security tool, the only metric that truly matters is adoption.
Absolutely. The best tool on the market, the one with the cleverest AI and the deepest graph, is the one your team actually uses every day to fix risks. If it just sits there, unused or misunderstood, you simply bought yourself a very